Welcome to the eOrganic webinar on the management of late blight on organic farms. We're very pleased to have you with us this morning. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. I'd like to briefly introduce the three presenters of this webinar, Sally Miller, Meg McGrath, and Alex Stone. All three are members of eOrganic, which is the Organic Agriculture Community of Practice on eXtension, a national web initiative of the Cooperative Extension Service. Dr. Sally Miller is a professor of plant pathology at Ohio State University. She researches sustainable plant disease management and the detection and diagnosis of plant diseases. Sally works closely with growers, processors, and extension educators to develop solutions to crop production problems. Dr. Meg McGrath is an associate professor of plant pathology at Cornell University and is located at the Long Island Horticultural Research and Extension Center. Her research focuses on the management of diseases of vegetable crops. In her work, she diagnoses disease problems for growers, evaluates disease management practices, and provides growers with current information on disease management. Dr. Alex Stone leads eOrganic and is the vegetable specialist and co-leader of the Organic Working Group at the Oregon State University Department of Horticulture. Her research areas include cover crops, organic amendments, biological control, and crop rotation for the suppression of diseases. In the 1980s, she co-owned an organic market garden in Massachusetts.
All right, thank you. All right, we have, during my part, the introductory part of this webinar, we'll talk about what late blight is. I'll describe the pathogen and the disease cycle because it's always important to understand the biology of the disease, the pathogen that you're working with, and then talk about the diagnosis, how you can recognize late blight and differentiate it from the other diseases that you may see out on tomatoes and potatoes. Okay, now a lot of you have heard, most people have heard about late blight, or at least they've heard about the most impressive and damaging epidemic that many have ever heard of called the Great Hunger, or also the Irish potato famine from 1845 to 1849, and that was disease that was caused by Phytophthora infestans, the pathogen we're talking about today, and resulted in the starvation of 1 million people in Ireland and an emigration of another 1 million people. It's had political consequences even to this day. This is the culprit, Phytophthora infestans, and what you're looking at here is a micrograph, a light micrograph of the pathogen, and these things I'm circling right now, those are called sporangia, and those are the units that blow around in the wind and land on plants and infect them, causing a disease. This is the disease cycle of late blight, and we'll focus mostly on the right-hand side of that slide. And again, we'll start here with the sporangium, which comes from an infected plant. Now, this is a pathogen that requires living tissue to survive. If once living tissue is gone, it also can die. These spores have a certain shelf life, we should say. They can survive under cool and moist conditions. In fact, it's cool, moist conditions that are very favorable for this disease. So where we tend to see it most is when the conditions are unusually cool for a season and also very rainy. Now, these sporangia can germinate directly, or sometimes they release these zoospores, and the zoospores are little spores that can swim. So this has been called also, besides a pathogen, a water mold. Okay, so these sporangia or the zoospores land on a plant and they can attack that plant. Now on a potato it can attack in fact on a tomato it can attack any part of the plant. On tubers it can infect in potato, and tomatoes you tend to see it on the leaves, fruits, and the stems. What happens very quickly, that's one of the reasons why this is such a devastating pathogen, because it attacks and destroys tissue very quickly. It colonizes the inside of the leaf or other part of the tissue, and then on the leaf it comes out on the underside, and these are those little sporangia again that can be blown off and land on other plant parts. Now in the case of potatoes, if it gets into the tubers, this can be a source of inoculum for the next season, because if the potato tubers, for example, are in a coal pile and the ones on the inside don't freeze during the winter time, then when the plant emerges, that the spores come along for the ride, and then eventually they get out there again, and in the next season those are a source of inoculum, and the disease cycle starts all over again. Now, in some parts of the world, and Meg will talk about this a little bit more, there's also the sexual reproductive stage of this pathogen, and in the end, what happens are oospores are formed, and oospores are resistant structures that survive during the winter. And then in the spring, in the next season, they can germinate, and those sporangia again will be produced and cause that cycle again. Okay. So these are some symptoms of late blight on tomato. For those of us who are plant pathologists, they're very distinctive, but for people who have never seen this before, there are other things that can look like this. But the things I want to point out, this is very fast. It occurs, it just pops up very quickly. You'll see this big necrotic or brown dead spot on the leaf with a ring around the outside, and that's the important thing, is to look for this kind of fuzzy ring. And I want to show you the bottom of the leaf later. Now, this picture just shows how massive an infection you can get almost, it seems almost overnight, certainly within a few days. On potato, symptoms are quite similar. This is the underside of the leaf where you'll see actually these very black and necrotic areas, and then on the outside there's a fuzzy sort of gray, white-gray look. The potatoes symptoms start off looking quite brown like this and can also turn black. You can get secondary pathogens in there as well. Now, one of the things to need to look at with both potato and tomato are the stem symptoms. And so this picture from Cornell University shows the very, I'm showing with the arrow here, these very distinctive black symptoms on the petioles and the stems of tomato, and you'll see those on potato as well. Now, on tomatoes, on the fruit, you get something that's quite distinctive. It's usually a very bronze color, at least initially, and then sometimes if you look when the relative humidity is still high, you may see a white fuzzy growth over here on the right, and that's actually that oomycete pathogen, the Phytophthora infestans, is sporulating, producing those sporangia we talked about. And so you can actually see that with the naked eye. So again, when I mentioned before, this is the necrotic down at the bottom of the slide, spot on the leaf, and then this is where on the leading edge, where there's still living tissue, is where that Phytophthora is sporulating. And if you look with a hand lens, you're going to see, this is actually a dissecting scope, but even with a hand lens you can see to some extent this sort of fuzzy growth. So I wanted to mention a little bit about scouting for late blight, and it's very important when the conditions are favorable, as I mentioned before, cool season and lots of rainfall, or at least high relative humidity or condensation. In greenhouses, condensation that occurs when you have a warm day and a cool night, and cool nights can be enough to cause this the conditions that are favorable for late blight if the inoculum is there. So if you have a large garden, or if you're talking about a field, we should really initially focus on parts of the garden or the field where the free moisture or humidity is the highest, because those are the places where it might start soonest because the conditions are favorable. The other place is to look where coverage by fungicide sprays is poor. So for example, even if you're using, in an organic system, you're using copper as a preventative, is that if sometimes there are edges of the field that don't get the sprays, those are the places to start looking. Now you should also do a good sweep throughout the field, but those are the places to focus at least initially. Scouting should be intensified during cool, wet conditions, as I mentioned before. And there are many extension organizations that are keeping track. So in most states, if you are have a subscription, or you can pay attention to the internet, you can find when the conditions are available or are favorable for this disease. The other point I wanted to make is that you should always scout very early in the morning, because that fuzzy growth you see on the edges is likely to dry up if the day dries. Conditions dry during the day. So early morning when the humidity is high is a good time to go out and look. Always look at the undersides of the leaves and deep into the canopy. You want to look for those stem symptoms as well as leaves that may be infected. In my own garden this summer, I had some very leafy high foliar material on my tomatoes, and I had to search way down in there, and I found one leaf that had late blight. So you really need to look very closely into the canopy where the humidity is high, and you're most likely to find it. And then if you have a hand lens, you can use that to look for those lesions on the sporulation on the outside of the lesions. Okay, so here are some of the symptom imitators, and I'll go through these kind of quickly, but one of them is early blight. And the big difference, again, folks that are used to looking at these diseases will easily recognize, but with early blight, you'll see this very bright yellow chlorosis and also oftentimes a bullseye effect on the lesions, so that's quite different than what you would see. And the fruit symptoms are also very dark and dry looking compared to what you might see with that bronzing with late blight. Potato early blight looks quite similar to early blight on tomato. Sometimes you don't see quite as much chlorosis or yellowing, but this again shows a very nice picture of those bullseye lesions. Septoria is another, Septoria is another tomato disease that can sometimes be confused with late blight because it can cause defoliation and can be quite severe. But one big thing is that you'll never see Septoria symptoms on fruits. You will get, it's favored by rainy conditions, but more by the warmer rainy conditions. And if you have a hand lens, when you look into on those lesions, you're going to see these little dots in here. And those are the fruiting structures of Septoria, and they will not be present when you have late blight, and it's a very distinctive diagnostic feature. Another one is botrytis gray mold. You can get stem cankers with botrytis, but often you'll see this very diffuse fuzzy growth, and it's a grayish, not a whitish, grayish brown, not a whitish kind of fuzziness. And again, sometimes you'll see this on the fruits, sometimes you'll see little spots, but you won't see that bronzing. Another one that this was a little bit tougher because it was almost kind of a bronzing on the fruits. This is a Fulvia leaf mold. Some growers just call it leaf mold. This is really not an open field problem normally. We see it in high tunnels and greenhouses. And what you'll see there is a very diffuse yellowing on the top. And when you turn that leaf over, there's the sporulation, again, it's sporulating, is producing spores there, and it's kind of an olive green color, and it's not just around the edges, it will be all the way across that lesion, at least initially. And the last thing I want to mention are some bacterial diseases, particularly bacterial canker, which essentially causes just an overall general necrosis, also causes symptoms on the fruit that are quite different from late blight. There'll be little spots, crusty spots, instead of that. You won't see that kind of bronzing. But on the leaves, sometimes people will think that they may have late blight because it can occur very quickly, and it's also very necrotic. But the symptoms on the stems are not that black color. They tend to be more like sort of a silvery color. The other thing that might be a little bit more confusing, but fortunately we rarely see it in this country, is soft rot. When plants are in a situation where they've been heavily over-fertilized, you can get this kind of black lesions on the stems, and that could confuse you. But again, you won't see that kind of bronzing on the fruits at all, and the leaves won't look the same. You won't find that ring. I'd just like to mention that you can find more information on disease identification with various bulletins, as are mentioned here, and also the Compendium of Tomato Diseases. There's a new one that will be out in the next year, so that will have very good descriptions and pictures. So that's what I have, and I'm glad to turn this over now to Dr. Meg McGrath.
All right, I'm going to talk about some of the key facts about the late blight pathogen that are important for management and some of the lessons that we learned from this year with the epidemic that occurred in the Northeast, and then focus on some management tips. So first I wanted to reiterate, because a lot of people use the term late blight for referring to the general late season decline that can happen with plants, that that's not the late blight we're talking about. We're talking about a specific disease. As Sally pointed out, it's the one that caused the Irish potato famine. So some of the key facts that are important to know about this pathogen that will relate then to how we manage it are, as Sally pointed out, it is an obligate pathogen. It needs living host tissue to survive, at least here in the U.S., because we haven't had the two mating types present to produce that structure that can survive over winter in the absence of plant tissue. It's got a narrow host range. So if we look at the host range, you can see there in the center, tomato, potato, those are our primary plants that are susceptible to this pathogen. One year we had a strain that went to petunia, and then there's a number of different weeds that also can be affected by the pathogen. Some other key facts: strains differ in their host virulence. Most of the strains that we've been dealing with, particularly the past few years, have been very virulent on potato. And often tomatoes do just fine. We'll see few symptoms. But this past year, we had a couple strains that affected tomatoes very severely. So there were situations where potatoes looked okay next to tomatoes that were severely affected. Another important fact that we need to know for management, as Sally pointed out, this pathogen produces many wind-dispersed asexual spores, and it happens quite rapidly. So that circle area has about 100,000 to 300,000 of those spores, the sporangia. And this can happen pretty quickly. There's some strains that in 4 days can go from the spore landing on the leaf and infecting to having a lesion like this. And that's why the disease can be so destructive and so devastating, can take off so quickly. That cycle goes so fast, there's so many spores, and they can move really fast. Another important fact is that here in the U.S., usually we've had one mating type occurring, and it's been a clonal population. So since there's only one mating type, you don't have sexual reproduction. You have those sporangia, which Sally talked about earlier. And the pathogen is just reproducing asexually, so everything's all the same. It's a clonal population. If you have the two mating types together, you get the oospores. Some recent genetic work looking at this pathogen has revealed that it's got a high genetic potential to change. And that's important to realize because it means that the pathogen, if it's allowed to fester and develop, and particularly if it starts sexually reproducing, we're going to start seeing a lot of variation, which could include its ability to overcome resistant varieties. So with that background information, that helps us to understand the sources of the inoculum and how late blight gets started. So the number one is infested potato tubers, particularly here in the Northeast. Remember, it's an obligate pathogen. So in an area where there is not plants surviving over the winter, the only way it can survive is living tissue, cannot get into a seed of true seed like tomatoes, so it can only be in potato tubers. Plants in frost-free areas, plants can survive, and they can produce spores, wind-dispersed spores, and that becomes our second major source here in the Northeast, or anywhere where you've got frost in the winter and killing of plants. We've occasionally, over the years, had tomato transplants serve as a source of inoculum in the Northeast. Growers who have had plants produced in the South and brought them up north have had plants come already affected. And we had one year that we had a strain that was on petunias and bedding plants. And actually that happened here in New York. But most of the time our primary sources are those potato tubers and then wind-dispersed spores. It's important to realize that the situation's changed in Europe. They now have oospores being formed in some areas, and this has happened because back in 1997, potatoes were brought from Mexico, and both mating types occur in Mexico, and they brought the second mating type over to Europe. It's important for us to realize because if that happens here, we'll end up with a situation like Europe where we'll have a second, an additional source of inoculum that can lead to epidemics. So with that in mind, it helps us to understand a typical late blight year in the United States. It usually occurs, but it's rare. It usually occurs where it's able to survive over winter, either as potato tubers, which is why it's predominantly a potato disease and primarily occurring in our main potato production areas, or in an area such as Florida where you've got plants surviving over winter. So that's where it usually occurs. Typically, when late blight is occurring, the affected fields are known. It starts in a production field. Growers realize they have it. We have effective communication. They let extension specialists know they've got a problem and what do we need to do, and other growers are alerted to what's happening, and that greatly helps to limit the spread because everyone knows about the disease once it gets started. That's what we've done here in the Northeast. We've had a really good communication system. And the pathogen population is typically clonal each year. We've had a listserv. It's also posted on the web about late blight occurrences. I just pulled up the one from 2006 because it also gives you some background information, just illustrates how often we see late blight in a typical year. So here's 2006. In September, there was a report, and no amount of late blight is too small to be ignored. So here's a single late blight lesion was found, and it was reported. And if we continue down this page, here's the rest of the reports from that season, and you can see there were very few reports in 2006, a typical year here in the Northeast. More late blight being found in the major potato production areas. That's a little more typical here in the Northeast. So in Maine, first detections of late blight have pretty much always been sometime during July because they're getting started in the potato tubers. So very regular occurrence of late blight in a major potato production area. Where I am on Long Island, and I've been here since 1988, we've had late blight occur 5 times over the years, and you'll see very variable of when it started, reflecting whether it started on potato tubers, as in July of 2006, or when we've seen it not until October. That's been from wind-dispersed spores that finally, slowly but surely make it to where I am here on Long Island. So last year we saw late blight in the end of June, and that was the earliest that we have ever seen it. Last year we had a unique outbreak of late blight for several reasons, and that affected management. We had affected plants and garden centers, and that's not happened before. We had tomato, therefore, affected before potato, and that's very unusual. We had gardens being source of late blight, and that's not happened before. This meant that we didn't know where our affected plants were, which kind of upset the management program. Not knowing where our sources of inoculum were, it made it hard to tell growers when they needed to be concerned, where late blight was nearby. Onset was earlier in the growing season than usual. We had highly favorable conditions for late blight in June and into July with a lot of rain and cool weather. And late blight occurred at farms and gardens where it's never happened before, which meant there was a lot of farmers and gardeners who didn't realize what they had to begin with, didn't know what to do. And some of our challenges, therefore, this past year was just educating people, informing them about what was happening, not knowing where those plants were, the onset being so early, conditions being so favorable for disease. And we also found we had inadequate supply of some key fungicides, particularly organic copper fungicides, which made it difficult for some of the growers in the Northeast to get right out and start treating because they couldn't get a hold of copper. One state didn't have any coppers registered, which made it challenging. And then we found this common perennial landscape weed that was susceptible, which therefore had late blight and could have been a source for more inoculum and leading to further spread during the season. So our late blight epidemic last year, it started in the cool, wet June, but it kept going. We had some outbreaks when it got into August when it was warm and dry, and it kept going through into October with new outbreaks in greenhouses. And what this illustrated to us is that high humidity is sufficient for favorable conditions for infection, at least 80%. And that's important to realize. So here's a field, an organic field, the end of August here on Long Island. Conditions had been really warm and dry. Was not expecting to see late blight. This is just his third planting. Fruit just starting to turn. And it had been about 10 days since the last copper application had gone out because it had been so dry and wasn't expecting to see late blight. But there's the symptoms that we were seeing. So in a matter of a weekend, all these symptoms appeared on the fruit, on the leaves. Some plants very severely hit, just too late to really start spraying. This grower did try to save the planting, but it was not possible. And here's the conditions we had in August. In the beginning of part of August, up until that last weekend, we'd had barely an inch of rain. Temperatures were warm. It certainly didn't feel like late blight weather, but indeed it was. And that's something important to realize. There is a forecasting system that's now up on the web that growers can use. And if you were to close in on this little red dot there, which says infection possible, it's That's near the location of where that outbreak occurred. So indeed, on August 26th, conditions were favorable for late blight. And so we've got some valuable tools to know in the future when conditions are favorable. But realize they're just telling us when conditions are favorable, not if inoculum is present. That's another important thing. If the pathogen's not there, you won't have disease. Now, our usual late blight population, as I've mentioned before, is that we have one genotype, asexually reproducing. It's just one mating type, and in recent years, it's been that US8, a potato strain. Last year, we had that potato strain, and so far we found, in addition, that there were 3 novel types on tomatoes. So we have more genetic variation last year, and a bit alarming is both mating types were found in Pennsylvania and Virginia. So our concerns for this upcoming growing season, particularly in the east, is that infested potato tubers are going to survive the winter, particularly in home gardens where the gardeners haven't been informed and don't realize that that could be a source of inoculum for the next year. We have late blight that has developed in some tomato crops in greenhouses. If those plants continue into the spring, that could be a source. And then the other major concern is oospores surviving over winter. Both mating types were detected. It's possible they were formed. We don't know. It takes time for the pathogen to grow together and for that to happen. Hopefully that didn't happen. We don't know. So factors affecting management with late blight, it's unlike other diseases. It's different from early blight and septorial leaf spot for a number of reasons, and that affects its management. It's a very destructive disease. Plants can get killed very quickly. The fruit can be damaged very quickly. So it's a disease we really can't live with. Septorial leaf spot occurs. You can tolerate it. You might have a little reduction in yield, but you're still going to get tomatoes. But that's not the case with late blight. And it can be really difficult to suppress after it starts. Like that field I showed you with the one organic grower here on Long Island. Just way too many symptoms when he first saw it. And all those abundant, easily wind-dispersed spores make it very difficult to manage. It means that everyone cares when late blight occurs because the spores are getting around to neighboring farms, unlike septorial leaf spot, which is going to move a lot slower because it's being water dispersed. It's not blowing around in the wind. It's an obligate pathogen, which it limits how it survives, and that is very important as we think about how we manage it. And another important thing to keep in the back of our minds is the impact that will happen if this pathogen starts reproducing sexually in the United States. In Europe, in some areas where they now have the pathogen reproducing sexually, it's greatly decreased how many people are growing tomatoes and potatoes, particularly in the home garden, because they have to use fungicides if they're going to get a crop. And that's something we certainly don't want to end up having to happen here, which means we need a good aggressive community approach to managing the disease. So our management steps are to control the source. You want to destroy potato cull tubers. Don't allow the pathogen to survive over winter. If you didn't get all the potatoes out of your field and the volunteer plants come up the next year, you want to get rid of those. We now have resistant varieties, tomatoes and potatoes. Realize it's not insurmountable. The pathogen can adapt, and we'll lose those. You want to use certified seed potato, so you're starting out with seed that doesn't have late blight in it. You want to be monitoring for occurrences of late blight during the season. What's getting posted on the web, that listserv I mentioned earlier in my presentation will be available to growers this year. You want to get out and scout frequently throughout the season. And if you see late blight, you want to report it. You want to let your neighbors know, and you want to let Extension know. Use preventive treatments when it's justified. When you know that late blight's in the area, you're going to need to keep spraying regularly. If you're going to control late blight, unfortunately, you want to take a community approach to management. I think this is really important. So you want to eliminate inoculum from your plants, not just to protect your crop, but to keep from your neighbors from having a problem. So you get into late blight, your fellow neighboring farmers need to know about it, and please let Extension folks like me and Sally know so we can spread the word as well. And if your plants become really affected, you want to promptly destroy them. So if you've got an initial find of just a few plants, you can pull those plants. Best to do it on a sunny day, and that's because the spores will be killed by UV radiation. You can tarp them. You can bury them. And also you want to promptly to destroy your crop once you're ready to abandon it, once you realize that you've lost the battle to late blight. And I will turn it over to Alex.
So I'm going to talk about management, both, let's see, oh, it's working now. Okay, so cultural practices, resistant varieties, and also materials or fungicides. And then I'm going to point out some resources that we have published at our eXtension Organic Agriculture site at eXtension.org. And those are an article on organic management of late blight, and organic management of late blight with copper, and also an article called Can I Use This Product for Disease Management on My Organic Farm to help you navigate choosing materials for late blight control. So I wanted to point out a project that I think not very many people in the U.S. know about. It's called Blight Mop, and you can see that here, Blight-MOP. And it was an all across the EU $2.5 million project looking to develop a systems approach for the management of late blight in organic potato production in the European Union. If you Google Blight Mop, you can find this website. This project, these are the various partners across the EU that were involved in this process, in this project, and it was a 4-year project. I first found out about it from this website down here, which is a link to the guy who was the lead of that from Newcastle University in the UK, Carlo Leifert, and he gave a PowerPoint presentation at this Organic Potato Symposium in Canada from the Organic Ag Center there. So if you Google Organic Potato Symposium March 2004 and then you look for Carlo Leifert's presentation, there's a PowerPoint presentation with a bunch of their data, some early data from that project, as well as a transcript of his presentation, and that was where I first learned about that project. There are papers now coming out of that project in the literature if you want to look there for some of their results. I was involved in an organic potato project here in the Pacific Northwest. We were working with organic farmers in Western Oregon and Washington on various issues they were facing in organic potato production, and one of those was late blight, and that project was funded by Western SARE. You can go to our project website, ospud.org, for more information. But I'm going to be using examples from those two projects as I talk today. So I just wanted to step back a little bit and talk more like a plant pathologist about how disease occurs on your farm. And this is called the disease triangle, and plant pathologists talk about this all the time. And essentially, to have a disease occur on your farm, you need the pathogen to be present. If you don't have the pathogen, you won't have the disease. You need environmental conditions that are conducive, which sort of favor the growth of the pathogen. And you need a host that's susceptible. And it's only when you have all of those 3 points of that triangle together that you get disease. So I'm going to talk about cultural practices first. And here, first, I'm going to talk about cultural practices that can help you either avoid getting the pathogen on your farm or get rid of it once you have it. So as you've heard both Meg and Sally talk today, one of the first things that you can do as a grower or a gardener is plant disease-free potato tubers and transplants. And that was one of the contributing factors. That's really one of the contributing factors that we've seen in epidemics both here in the West and also, as you've heard, in the Northeast. So that you really want to buy your seed, your potato seed and your tomato transplants from reliable sources. And you want to inspect those plants and your potato seed for disease when you receive them. And so, as Sally was talking about diagnostics, it's important to be able to use those diagnostic tools to look at your tubers and look at your transplants to make sure they're not diseased when you receive them, and then obviously return them if they are diseased. This is a really big problem here in the Pacific Northwest and a contributor to disease epidemics here. People, and this can be on a small farm or on a large scale sort of wholesale production situation where farmers either have sort of loosely managed compost piles or are just throwing their cull potatoes into a pile in a corner of their farm. And as Sally mentioned, if those are not completely frozen over the winter and you have late blight in some of those tubers, this is a great reservoir because the pile of tubers protects living tubers in the center of the pile. And so disease can move from one to another over the winter, and then those can sprout and start sending out those sporangia that both Meg and Sally were talking about and infect both your own crops and also your neighbor's crops. So it's really important to think about on your farm where you might have some of these reservoirs, or if there are some in your neighborhood. So you want to destroy all those overwintering inoculum sources. These can be spread out and frozen, buried, or composted properly, and then you'll kill that inoculum. Because as they pointed out, if there's not oospores being developed, which we haven't seen in the Pacific Northwest, then this pathogen is an obligate parasite, and it can only live in living host tissue. So once you destroy that tissue, you get rid of that pathogen. So one thing that people do talk about is destroying diseased plants when you first see them. And this information is really from a Michigan State publication, which they investigated this as a control strategy. And I think and the Blight Mop Project looked at this also. But one of the sort of caveats to this is that, as Meg was sort of pointing out in one of her slides, it takes 3 to 7 days, or she said I think 4 to 10, depending on environmental conditions, from when you first get infection of a plant by the Phytophthora sporangia to when you actually develop symptoms that you can detect in the field. And during that period, you can get new infections on neighboring plants. So by the time you start noticing symptoms in your field, particularly if you haven't been scouting really rigorously, you will probably have infections in neighboring plants. So many apparently healthy plants will have to be destroyed in the area surrounding those first ones that you see that are symptomatic in order to get all the infection out of that area. So Michigan State recommends that all plants in a 100-foot radius from the first symptomatic plants must be destroyed. Now that may sound very radical, but that's just sort of trying to be conservative. So one thing, and Meg suggested this also, is that if you have a variety of plantings and they're somewhat spatially separated and you see late blight coming into one of those plantings and it gets going, but it hasn't moved into some of the other plantings, you might be able to destroy that planting to prevent the movement of those sporangia into subsequent plantings. So that is a possibility also. So we've talked about how to both avoid or destroy the pathogen. What about managing the environment? As we've heard both the previous speakers say, late blight is a water mold. It really likes high relative humidity and moisture on the surface of the foliage of your crops. So this is very helpful in the West where it doesn't rain so much during the summer. If it rains a lot, then this may be less of a useful management strategy. But nonetheless, it's really important to design your cropping system to minimize leaf wetness. So plant your rows parallel to the prevailing winds. Don't plant in areas prone to standing water or impeded airflow, like if you plant tomatoes next to tall trees or something where you don't get good airflow. Manage your irrigation and maintain your irrigation to minimize duration of leaf wetness. Irrigate early in the day so that the foliage dries out before the evening, and particularly in tomatoes, use drip irrigation if that's appropriate and practical. Don't over-apply N, and you've heard previous speakers say that. You want to manage your canopy size. You don't want a overblown canopy, which then is very slow to dry. And also, high tissue N can make your tissue more susceptible to infection. You want to stake and prune tomatoes to promote airflow, and also manage weeds. If you have a lot of weeds in your potatoes or in your tomatoes, again, that adds to the size of your canopy and slows down drying. So that's the environment, and then lastly I'll talk about plant host resistance. That's a really important management strategy. In fact, in the Blight Mop project, they basically tried an absolutely amazing variety of various cultural management strategies, and so they determined at the end that what they really needed was more resistant potato varieties. That's also a conclusion here in the U.S. In the OSPUD project, we worked with Isabel Valles and Solomon Yilma at the OSU potato breeding program, and they work as part of the Pacific Northwest potato breeding program. And
they did both experiment station field trials, and then we also had our farmers grow some of the more promising varieties. And what we showed is that Jacqueline Lee, which is a Michigan State University release, it's a yellow-fleshed, yellow-skinned potato that our growers were looking to substitute for Yukon Gold. And actually, the chefs that buy from some of our farmers actually preferred this in culinary quality to Yukon Gold. So that's a really great variety. Defender is a University of Idaho release. It's a fresh market russet. We have some growers who have switched over to this. They really like it, and actually it has really nice flavor. And that has very strong foliar disease resistance. And then Ozette is actually sort of a slow food specialty tuber here, commonly grown in the Pacific Northwest by some organic farmers. Very nice flavor. And that, although I have never really heard that reported previously, does have very strong foliar resistance. David Douches, who developed Jacqueline Lee, I've talked to him, and he has a lot more late blight resistant varieties coming out of his program. I know that's true in the Pacific Northwest program as well as in other potato breeding programs. So do stay tuned. You'll be seeing more late blight resistance coming along. I have not worked with tomatoes for late blight resistance, but these varieties I've found reported or have been reported to me. Meg McGrath pointed out that Plum Regal and Mountain Magic, some Bijo seed varieties, are resistant to late blight. Plum is obviously a plum. Mountain Magic is more of a main season tomato. And then the Washington State University Vegetable Plant Pathology Program did some trials, and also Organic Seed Alliance in the West, and they have shown that Stupus, Maxwell, Cherry, and Juliet have some resistance to some of the tomato strains. So again, I'm sure there will be more tomato varieties coming along in the pipeline, so be looking for those. And resistance really is the organic farmer's ally and friend, so that's an excellent and sort of first-order management strategy. We've heard other speakers talk about the coppers. I did want to talk to some extent about materials. Blight Mop did a lot of work looking for alternatives to coppers and alternative cultural strategies, but in the end they said that copper really still remains one of the strongest management strategies for organic farmers that cannot control their inoculum. So I did just want to mention some things about the coppers. So coppers are protectants, as Sally mentioned, so they have to be applied to the foliage before infection. That's really important. They don't have any kickback activity. So coppers must be applied regularly throughout the potato or tomato production season to protect newly emerging plant tissues. Coppers are considered synthetics by the NOP, and they are permitted with restrictions. They must be applied in a manner that minimizes accumulation in soil, which of course very few farmers have in their hands information on how to determine whether or not their applications are accumulating copper. The Blight Mop program was working within these new, more strict EU guidelines. The EU actually has a rate restriction. You can only apply 5.4 pounds of elemental copper per acre there. It used to be a higher limit, and actually in some countries in the EU, no farmers, organic or otherwise, are allowed to use copper at all. And the Blight Mop program did control late blight with 6 sprays of 0.9 pounds per spray, and this application rate actually meets that 5.4 pound guideline. We did a late blight materials trial at OSU here in Oregon in 2007, and we applied 4 applications at 1.9 pounds of copper. But I do think it's possible that you could apply copper at a smaller quantity and achieve control, particularly if the timing of those applications is appropriate. Here is some of the data from our 2007 trial. This data is very similar to the many, many trials that were done during the Blight Mop project. Basically, what you see here, these 3 lines, the blue, green, and pink, are different copper materials. And they, as you see here, over time, very much slowed down the epidemic. The black line here is the water control, and essentially there was 100% foliar necrosis after several weeks when only water was applied. we did have a variety of non-copper materials, and as was shown also in the Blight-Mott project, those did not seem to have very much efficacy. This is to address that issue of trying to find materials that can replace copper, because that's a very strong need in organics as well as in non-organic production systems. There was a lot of work in the EU looking for alternatives to coppers in terms of materials, and this is the report that came out in 2007 in the European Journal of Plant Pathology. This paper is available online. They essentially looked at 53 various copper-free materials, from plant extracts to microorganisms, and then they compared that to 5 different copper preparations. And what they found is that, and they also looked under very controlled conditions in the laboratory and in growth chambers, and then in less controlled conditions in the field. And what they found is that 11, or about 20% of the non-copper products were actually effective in more controlled experiments, but efficacy was lost as they moved into less controlled environments, as they moved into the field. And what they saw is that the rain fastness and the persistence of these non-coppers was very low compared with the copper materials once you got out into these varying environments in rain. So their conclusion was that the failure of some of these non-copper materials was really due to a lack of stability in the field and not really to their inherent lack of efficacy, which I think is really important. And so they also showed that you could reduce the amount of copper and make copper applications more effective if you used proper timing. And we heard that from Sally and Meg, that you want to actually apply them according to when the environmental conditions for late blight are most conducive. And so they recommend that we, in the meantime, as we try to make some of these non-copper materials more stable, that we learn to use coppers more efficiently. So in conclusion, I just want to mention that we do have 3 relevant articles published at eextension.org in the organic resource area. This one is the organic management of late blight of potato and tomato. And then there's one also on copper products, and then also an article on sort of navigating the NOP and trying to understand which products can actually be used to be in compliance with the National Organic Program. And so at this point, I think we're going to have several more questions asked of our audience, and then we'll spend 15 minutes answering your questions that you've submitted.
Okay. One of the first questions was, does the disease spread on hands and clothes and tools when scouting? And how's that, implications for that for moving the disease around? Would Meg or Alex, would you like to take that one?
Well, I'd say certainly as you disturb leaves, you're going to disturb spores. But you're not going to move the pathogen as importantly as you would if it was something that was only in the sap of the plant, like a bacterium. Then if you're getting it on your hands, such as when you're pruning and you're moving down the line, it's a much more important means of moving the pathogen. Any work you do in an infected field in the middle of a sunny day, any of those spores that get disturbed will be affected by the UV radiation. It's a very good killer of spores. So you might think about doing work on a nice sunny day,
Right.
and that will help limit the spread.
Yeah, don't go into fields when they're wet in general. That's a good practice, because you're more likely to move a pathogen when it's wet, and particularly one like late blight. So you never want to work in a field or scout a field when the foliage is wet.
Well, except that, Alex, this is Sally, I would say that you do need to have at least, if you wait till it's too dry, then you won't see it very easily. So if you are an expert and you really know, you can wait a little bit because you can look at other symptoms. But that's just another point.
That's true. That's sort of a difficulty with scouting for late blight.
But then again, a lot of times you are looking for late blight kind of in edge areas where maybe, as I mentioned, maybe the fungicides, so that might be on an edge of a field if you get started there. But again, it's only one person. It's not a lot of workers in there harvesting tomatoes or something. So it's a little bit less bad than handling those other operations when the field is wet, which we always recommend not to do. Okay, so the next question, and a lot of them have come up, so that's great, but I'll just take one of the earlier ones then. Meg, you gave us a slide on hosts that are plants that are susceptible, and the question is which weeds are susceptible to late blight, and I think that comes in terms of which ones do you particularly want to worry about it in terms of being a source of inoculum.
It varies with the strain that's present, and the one we had last year, that bittersweet nightshade, was a definite, very susceptible host. Hairy nightshade, anything within the family, the Solanaceous family, I'd be concerned about. And the picture with the names will be posted on the web, and you can certainly check back and look through that list.
Okay, great. So we've got that one. So then we have another management question that basically there are two questions that are sort of similar, but what is the best way to destroy a crop in an organic system?
Depends on the crop. I think pulling and tarping, and that's actually one I heard from an organic grower up in Maine who's been battling late blight a lot in recent years. Pulls, tarps, because underneath the tarp prevents the spores from leaving, and the plant's going to heat up and get killed faster underneath that tarp. Another approach would be to bury it. You could certainly disc up a crop. I would do it in the middle of a day when it's sunny so that any spores that get dislodged are going to get killed by UV radiation.
In the Blight Mop project, and again, they were only working on potatoes, and in general they were working on larger scale potato production. They tried flaming, using a flamer, a tractor-driven flamer, or a handheld flamer, and also flailing of potato foliage. And while both of those killed the foliage, they didn't really see a lot of improvement in yield, and it's partially just because if you kill your potato foliage, you stop growing your potato tubers. So with potato, it's a little bit of a different issue. But you can...
Potatoes, the time to take out the potatoes is before you see symptoms on the main stem. And that can kind of help you decide when it's time to really take it out, because it's the symptoms on the stem, those spores that can get washed down the stem in a rainstorm straight down to where the tubers are.
Right, and actually that's something that I didn't mention, which I should have, which is keeping good, if you're growing potatoes, having high hills and managing your hills so that you don't get a lot of cracks in them can help prevent that movement of spores down into the tubers. And people do, if you do see late blight and it's fairly later in the season in potatoes, you can kill your foliage and prevent those tubers from getting down into prevent the spores from getting down into the tubers. So killing foliage is actually a recommendation in potato production anyway, but you want to do it several weeks before you harvest, so all of the pathogens, the propagules, are killed before you harvest so that they don't get onto those tubers.
Okay, very good. There's a related question, is how long do spores of Phytophthora infestans survive before they have to find and infect another host plant?
Depends on how sunny it is. If it's a cloudy day, they can survive for many hours. My understanding is it's about 2 hours in sunlight and they've been killed.
Okay, great. Now, there is another question here, as someone asked, didn't the sexual form of Phytophthora infestans that occur in the United States in the 90s? Can you, Meg, talk a little bit about what that wave of P. infestans that came in then, and what that means? Like, shouldn't we have expected oospores by now?
My understanding is there was a shift in the mating type that we had. So yes, we brought in another mating type, but that strain completely replaced the other strain. So unless you have the two occurring together to have that opportunity for sexual reproduction, if one strain outcompetes the other one very quickly and there's no opportunity for sexual reproduction, or people are really good about managing it and that the pathogen doesn't have time to interact, you won't have oospores produced. And that's been the situation. We do have both mating types now in Florida. There has been some concern, but they have not gotten evidence yet of oospores. But realize in Europe, it's a very recent occurrence that they're starting to see otospores. And I think that's something we just need to keep in mind, that it could happen here.
Okay, great. We have then several questions about copper. One of them is one grower felt that it was the cost of spraying was very prohibitive. And once it wonders what's the cost analysis per acre of spraying throughout the season. Do either of you have a handle on that?
Well, we looked at that in OSPUD, and I don't have the numbers in front of me, but I guess it sort of depends on how, if you just look at the cost of the material, it really, and you compare it to the cost of losing your crop, it pretty much pencils out, or it certainly did in the production systems we were working with. But that's obviously something that would be up to the individual farmer, because it would, depend on how valuable that crop is. But the copper materials are not that expensive, and they do provide if you start early and you apply regularly, they can really manage a disease that otherwise could completely destroy your crop. So it seems for some of the farmers who use coppers as a result of the OSPUD project, it really did seem extremely cost effective.
Okay, so then another grower said, how do you manage total copper applied to a field in a year with as many days of rain as 2009? What I think that means is maybe not as much of a question as a concern is how do you actually do that when you have so much rain? I mean, did I ask the question about the rain fastness? Because that came up, is what is the rain fastness of copper, or these copper compounds that are available for organic use?
My understanding is that it's quite good, that you'll get a week's worth of residual out of them. I know there's been a lot of concern that they get washed off in the rain.
Yeah, when I've talked to some plant pathologists who have more familiarity than I do with copper, copper's inherently, even without any kind of an adjuvant, are very sticky, just sort of chemically they're very sticky. And you see that when you apply them. They have a long residual. So it's really more the issue of covering the new growth, because your previous copper applications actually can have a lot of stability and they stick fairly well. But yes, I mean I think having a really good sprayer that gives you excellent coverage with a fairly low application rate, so that is important. And then also trying to find, as I think is going to happen, we're going to start seeing more copper materials that can be applied at lower rates due to their particular formulation, so that you could apply it at a lower rate in each specific application.
Yeah, there is a new one. The COSIDE 3000 is due to be out in a OMRI-approved formulation this season. And that is a more bioactive copper. So there's one where you could use a lower rate and keep the amount down.
Right.
The other thing I look at is how rare late blight has been outside of major potato production areas in an area where you've got a winter to kill the plants. And I think that tells us this is a disease, if we really can get on top of those overwintering sources, we can reduce how much copper we need. Just don't start out with it at the start of the season. In a normal year, when it's coming in on wind-dispersed spores from a distance, here on Long Island, we haven't seen the disease often until September, October.
And that's a good point. This is Sally again, Mig. And what we found when that sort of last big outburst we had here in Ohio anyway, in the 90s, is that mostly we were seeing it in the fall in greenhouses, where they were not keeping their temperatures up as the temperatures started to decline, to go down in the fall. So it's really important to not have those big differentials between and allow the condensation in the greenhouse, high relative humidity and condensation. So I think once growers start figuring out that they had to be careful in the fall, we ended up seeing a lot less late blight in the greenhouses and tomato greenhouses. So I think once people have had this experience, they start to learn pretty fast what they need to do. What we're having different here is that we had such such low temperatures. It was a very cool growing season in the Northeast, combined with a lot of rainfall for parts of the season. It just took everyone by surprise, and of course the introduction of inoculum is a little bit different. Back onto the copper issue, question is, do you recommend using a surfactant with copper?
Meg, do you have an opinion about that? From when I was talking to people about using coppers in the OSFED project, and we did not use an adjuvant, that the coppers are really pretty sticky, and we didn't seem to have a problem without using one.
Okay. So
my reaction has been to look at the label.
Right.
And if an adjuvant's needed, it's going to say on the label.
Right.
That's a good point.
And often that's how they're formulated, is with adjuvants.
The next question is, do I need to be concerned about food safety when spraying copper on fruit that I will be harvesting shortly?
The only issue is with people who have a copper sensitivity, and there aren't many people with that problem.
Oh, answer that again.
But that was one issue that came up this year.
With people who have a copper sensitivity?
Yeah, I've forgotten the name of the disease off the top of my head. I have it written up in my frequently asked questions on the web.
Okay.
Those are the only people who need to be careful. The other thing to be aware of if you're spraying copper is it's an irritant to eyes. You need to have your eyes protected when you're spraying. You get copper in your eyes, you can cause irreversible eye damage, and people need to be aware of that.
Okay. Another question. Wow, there are a lot of questions that are coming up on coppers. Another one, how many applications should we plan for 2010 if we still want to grow heirlooms? It's a touchy question because we don't know what the weather will be like, but do you have any suggestions?
You could spray as frequently once we go through the re-registration process as often as every 3 days. Hopefully you don't need it. I would, as you pointed out, I guess as Alex pointed out, it's the new growth that's important to protect, so you may need to spray more often when you got a lot of flusha growth. I would pay close attention to reports of late blight so you know if the inoculum is even around. Hopefully we won't have another bad year. And watching that forecasting web page that tells you when conditions are favorable, because that is looking at high humidity, which is something you may not realize as we got into that problem last August where we had that spell of high humidity that gave favorable conditions for late blight. So I'd very much spray based upon need. Inoculum present, conditions favorable.
Right, and that was one of the recommendations of the Blight Mutt project, really would be to identify where, if it's available in your area, who is monitoring those conditions and creating those predictions, and then work with that information to time your sprays so that you're putting on only what you need when you most need it.
And if we're all working together, if everyone is willing to speak out when they see late blight on their farm, we'll all know, or garden, we'll all know where it is and when the rest of us need to start reacting. And I think that will be very critical.
Okay, so we have a comment here that this sensitivity to copper is called Wilson's disease, and this person has said you better believe there are food safety issues with copper. So I think that that's something that people should be concerned with and can look it up in the on the internet. But again, to me, it's partly just is a matter of looking at the label and making sure that copper is used as little as possible and always in according to label requirements and recommendations, as well as NOP requirements. Do you have any?
It is something that we biologically need, so it's not something
but not
that
too much.
Applying that right, we don't need too much, but it's not as though we're applying something like arsenic that our body does not want. Our body can use some copper. I do remember now that is correct. It is Wilson's disease.
And I always recommend to gardeners, at least, that they always wash their tomatoes before they consume them anyway. That's just a common precaution. Of course, for growers, that's another story. Many of you are using dump tanks and will eliminate some of the residues that are on the surface of the fruit anyway. I think you always have to be concerned about the people who really are exposed to any types of pesticides are the producers, are the growers who are putting them on. So those are the people who have to be particularly careful. Okay, there was another question. Meg, how often have late blight infection been seen on petunias?
1 year to my knowledge.
Okay.
So that was one strain that came in on petunias.
Okay. There's another question, is there any benefit of grafting? And I could answer that one. The benefit of grafting would come from using as a scion, or the top of the plant, a variety that's resistant. And if you happen to have, particularly wanted to have something that's resistant to some root problem in addition that you're having. So, but as far as I know, we're really talking with tomato as primarily a foliar problem. You know, it may not be any worth the additional costs because essentially your resistant variety is already, the top of it is already resistant. Any other comments on that, Meg? Or?
No, that was good.
Okay. How likely is it that we will get another widespread epidemic started by tomato plant transplants from big box stores? Meg, you want to?
I think that is unlikely. There's a couple of us who have started working with the company that had those plants last year, and working they're going to have them the greenhouses independently scouted this spring. They're going to be on a good fungicide program. I think they're going to be very much on top of their plants, and I think we'll all be out looking. More my concern for this year, as I mentioned in my presentation, is potato tubers surviving and people not recognizing that could be source of late blight.
Thank you for joining us for this webinar. To find out about upcoming webinars, visit the eOrganic website at http://www.extension.org/organic_production and click on the webinar link. Thank you.